Okay, it seems like we spent a long time just getting the data into R, but I will guarantee that things will be things will get easier. Like the first time, it just takes some time to wrap your head around it, and once you kind of learn it, you'll be able to do it a lot faster. So now we are on the section tips for formatting your Excel file for R. So click on this code block, and again, this is a way to kind of include a graphic. So this is the general format, if you can do it, to format your Excel tables. So each column should be a variable that you measure. So in this case, you can see there is country, year, and I apologize, this is a little hard to read, but it's so each of them should be a column. And within each column, remember, they should be the same data type. So, you can, like for country, obviously we need to use character for that. But don't mix data types in a column. Each row should correspond to an observation. And so in the case of our example, each row corresponds to a patient. And each cell should have a value. So this is a format, I mean, it seems very basic, but Hadley Wickham and a number of others have talked about it, and it's called tidy data. So, and this is the way to be successful in R, is to try to get your data into a tidy format, because it lets you do all sorts of things in R. So now I'm on this section. Transpose is your friend in Excel. So what if you had your data in where the variables were in rows? So don't worry. So remember, you can transpose a table. So you could copy it to a new sheet, and you can use the transpose option when you're pasting it. So that will basically transpose your rows into columns. So every column should have a name. If it doesn't have a name, this can cause some problems, because R expects every column to have a name. So its guess for the number of columns is using the header. So if you don't have a name, if your last two variables don't have a name, R is going to get confused, because it's going to encounter the next row, and it's like, wait, I wasn't expecting those two variables to be there. And also, please remember, like, you should every name of your columns should begin with a letter. So numbers and characters like dashes, try to avoid using those. That's why I use underscores. So now we're on number 4. Color information is really hard to get into R. So I will say, I think it is really useful to color cells, to kind of let you know things about those cells. So like if they were a patient, and, for example, if they were in the emergency room, or in the emergency room, or they're back in their room, that might be one way you would use color. But if you want to get that into R, you need to encode that into another column. And the last one is extra lines are okay. So you saw we can use that skip argument to skip extra lines. Sometimes better to have a notes sheet, like a separate sheet where you put extra information in there. Or I'm not going to get into this, but a lot of the times it's very helpful when you're sharing data with someone to have something called a data dictionary, where you actually explicitly define what all of the columns mean. Okay, so this is kind of the last section where we're going to go into base R. And so now we've loaded our data. So we've got our BRCA clinical table in there, our BRCA underscore clinical. Aaron, are there any questions?
Nope, we're all good.
Okay. So the table format that we've been talking about, they're called data frames. Underneath them all, what a data frame actually is underneath is a bunch of vectors that have the same length, but they can be different data types. But the reason why this structure works really well is that you can use it you use it for kind of grouping, doing kind of grouping questions, and naturally a lot of data does not have is not always going to be the same data type. I mean, sorry, MATLAB folks, not everything is a matrix. And this, like the flexibility of having different data types and available for different columns. So I am going to make the terminology switch. So I am only going to refer to variables as the columns. So I'm never going to call them an object. So anytime I say variable, I mean a column in a data frame. So let's learn some more things about the data frames. So now I am on the section data frames. How do they work?
Ed, question.
Yeah.
If data are incomplete, like a cell has missing data, will R fail to read the cell?
So that's a good question. So if it is blank, and this is why you have, and I've had this be a problem, is that sometimes if you try to mix like blank cells and you include NAs, it's actually kind of a big headache. So you should try to be consistent. So they should either be missing data encoded as NAs or they should just be blank. So that's just one thing that is kind of is difficult. Did that answer your question? I don't know, my chat window keeps on disappearing, Aaron, so just please let me know. Okay, so the very first thing we're going to do is we're going to learn about the dimensions. So what are the number of rows and the number of columns in our data? So we can do that with the dim function. And so the first value of dim is always going to be our number of rows. So we've got 1,095 rows and 16 columns. So this is a useful function, is head. So this will show the first few rows of the function. So if we do head on BRCA clinical, you can see that it'll show the first 6 rows of the data. And to see the other columns, you have to click this little arrow here. And so you can kind of confirm that everything was loaded up correctly. So one thing, now I'm on the section called column names. So a lot of the times we're going to need actually to reference the names of variables in our data set. So sometimes you just want to have like, a little reference of all of the names of the variables in your data set. So you can do this with this function called call names. So that's short for column names. So we're going to run that on BRCA clinical. And you can see it returns a character vector, and it has all of the column names in your data set. So I use this all the time because it's hard to remember the name of a column. And again, R is very picky. It is case sensitive. And so you have to know the exact way that the column name was typed in. So there is a corresponding function called row names. We're not going to use this. It's because our data doesn't, we don't have these kinds of row names. It's not really informative for us. So we saw that there was one way to kind of view kind of the function. Actually, we looked at two ways to kind of view the data frame. Sorry, I meant data frame when I said function. So one of them is this glimpse function. So again, this just kind of gives us information in a different way. So it tells us the number of rows and columns. It also gives us the column names. And importantly, it gives us what the data type is. So the CHR is short for character here. And the DBL is short for double. So that's, remember, our numeric representation. So when you have a chance, I want you to identify the numeric variables in the data set. That'll be useful in this week's assignment. So Aaron, any questions so far?
Not so far.
Okay. So now I'm just on this line. It's line 315. It says another useful command is view. So it's going to open up a spreadsheet. We saw basically that clicking on the environment opened up this spreadsheet-like view of the data frame. You can also do that by using the view command, and view is uppercase, and that will open that window. So the last portion is of like understanding our data frame is that we can use the summary function. So this kind of provides different information than the glimpse function. And for character data, it's a little less useful. But for numeric data, like age at diagnosis, it will give us ideas like what is the mean of our variable, what is the maximum of our variable, are there any missing values in that variable? So this is kind of a good way to get an overview of at least kind of the numeric values. So now I'm just